page and then to go to downloads, etc., etc., etc. Everything is explained here in detail. Be aware that you should install 17.12 and not the 20.03, although 20.03 works. Later on, there might be some issues. It's all there, and make sure that you install the MinW setup, which includes the compiler for the Windows operating system for Intel and AMD type processors, as I've discussed in class. Okay. These resources that I have here is there for a reason. It's for you to use. Okay. Start using them. Okay. Then in terms of exercises and so on, other than what we already do in class, here is some self-assessment things that you can try out. Okay, my question to you is, have you tried them out? Have you gone through this page, looked at everything, tried to understand, see how things is working, what the output is going to be, etc., etc., or are you still waiting for things to just happen? Okay. For those of you who are repeating the subject, you can't do the same thing and expect a different result. So it means you need to change something. Okay. So there's some exercises there. And then in terms of the little booklet that I've written, there's some assessments with things that you should know. So for knowledge component number 1 and knowledge component number 2, the two things that we've already touched on, my question is, do you know all these answers? Do you know all these outcomes? Okay. If not, then you are not doing your part. You are already behind. That means that you have to catch up. Okay. Please, guys, I can't force you to do anything. All I can do is I'm an administrator. I can only certify that you've handed in something and that it meets the requirements or not. Okay. So, yeah, please start doing these things. Make sure that these things are in your head and that you understand what it's all about and where we are going. Otherwise, you're going to have a hard time in this subject. The subject is not like other subjects where I teach you a little recipe and you regurgitate that back to me. Okay, so I teach you a little recipe, say sorting, and then in the exam I ask you sorting. It doesn't work that way. I might teach you how to do sorting, and then I might ask you what is the middle element. And then you have to sort everything and then find the one which is in the middle. Okay, so you need to be able to use the sorting algorithm to do something else. And I expect you to demonstrate that something else, which I have maybe never taught you. Okay, not directly. This is how the subject is. Okay. I know there's all kinds of other things that come into play, pass rates and finances and all these types of things, which kind of bears down to me watering down what I'm teaching you, expecting less of you. But last night I just realized again how important the task is at hand. I had a student contacting me saying, thank you. He was, he went for an interview and he got a job opportunity. He was offered a job opportunity, and purely on the fact of the technical questions that they asked him, he was able to ace those because he knew what he was talking about. He knew his shit. Okay. If you don't know your shit, you will not be able to pass the technical interview. You will not be appointed in that position. So get your shit together and work hard, and you will also get employment. Otherwise, as I said before, you will just be a highly qualified burger flipper or barista. Okay. If that is what you want, by all means. Okay. That's enough from my side preaching about things. That's not what I'm here. Although I feel it's important that I do share this type of information with you. So, yeah. Okay. Can I see, is there anybody that is still struggling with anything in terms of getting to this stage where you've got a project set up, where this template is, you are able to compile and run this template? Anybody that's still experiencing some issue of some kind? Okay, so I assume then that the whole class is ready to continue with today's class. Okay. So again, what I like to do, and what I suggest you do too, is that after each day, every day that we start a new class, we take the previous work and we make a copy of that, and then we continue on the previous work, but we've saved a copy. So I'm just going to go through the steps of how one would go about doing that. So first of all, we close the project. So if there's any changes or whatever the case might be, can just make sure that it saves it. So now we need to go to the directory where we are working. So this is the one that we saved. So we normally say Control-C, Control-V. So Control-C is to copy, and Control-V is the shortcut for pasting. Then we are going to rename this one. So now we are going to do class 2. And I normally delete everything except the .cbp and the .c file, because we are going to rename things, and then those things are just be hanging around there, and we're not using it, so we're not sure what's going on. So it's better to just keep these 2 files. I then just rename my project so that it's similar to the directory name that I would get. So normally, if I go to create new project and follow this route, then that structure will be created for me. But because I am copying something which I previously used, now I have to make sure that I copy the structure properly. Okay, so once I've renamed this, I can now either double click this or go to open an existing project. And it should open everything like before. And now everything that I've done before is available for me to use. Okay, so this is the process which I suggest that you do at the beginning of each class. The way in which I teach is we start with something small and then we add something to it, and as we add things, we are building towards a bigger application. So we add little by little by little. But if we use the old stuff, then we are kind of deleting what we've done, or not deleting, but as we add, then we don't know where we stopped previously. So if we want to revisit that, either as an exercise or to go into a different direction or whatever the case might be, then we don't have that template anymore. Okay, so it's kind of a place where we can reset back to and then start from there and try to follow. Okay, you will also notice that this name here is still class 1. So you can just go to project and properties and then just change that as well. And now this name has changed. Okay. We did the same thing yesterday when I showed you how to copy. Okay, so this is something that you can do at the beginning of each class that will assist you in maintaining kind of a track record of what we've done before, where we've stopped, what was added, and so on. Cool. What are we busy with? We are busy with developing the knowledge of understanding a language, which is easy for us as programmers to understand, and then convert that into something which the microprocessor can understand. And in particular, what we are going to do is we are going to learn the ANSI C language to assist us in that. Now, just like with English, where we've got characters making up words, and those words have very specific meanings, and we construct them into a sentence, and the sentence conveys some information. Similarly, when I write a C program, there is a structure to everything. And what we are going to do today is to spend some time on this basic structure to understand where it comes from and how I can get more information on the programming language as we go along. Okay, so we are going to spend a little bit more time on just understanding how things work before we actually dive into the programming language itself. Okay, so just like with a house that has a foundation and a structure where there's walls and a door and windows and a roof, and this is a house. Similarly, when we program, there's a structure to everything, and that structure has meaning for the interpreter. So if we don't adhere to that structure, follow those rules very carefully, then we end up where our code, although it compiles, doesn't exactly do what we expect it to do. Okay, so let's look at this structure and see the different parts. Again, if you go to the website, you will see that the website has a little template here, and that there are some lines that explain what's going on. Okay, and when you go onto this highlighted part, you'll see that it highlights the lines in the code so that you can know exactly what I'm talking and where this sentence refers to inside the code, so there's no ambiguity about it. Okay, so you can see that these different parts are highlighted and there's an explanation. So everything that I'm saying now to you is also on the website. So if you don't want to follow a 3-hour video to understand what's going on, you can go onto the web page and then just read everything and follow by just reading and copying and pasting. Okay, so you can actually copy and paste all of this code and replace the code inside code blocks with that, and it will be slightly different because here's some additional things that I have added in, so it's some ways along already. Okay, but just as a reference, everything is here. Good. Okay, so let's get into it. So inside my IDE, you will find again some icons at the top, which these icons we use to build and run our program. They are also duplicated inside our build menu, so you can also activate it from there. Okay. So what is the actual structure? Well, let's comment out something. Now a comment is 2 forward slashes followed by some text. This we call a comment, and we write comments to inform us of something. Maybe we want to place a to-do comment. Okay, a comment to yourself, or I must do something, I must read something, or this has reference to whatever this variable is initialized there. Whatever information, additional information you want to add to your code, which is not code, we do with a comment, 2 forward slashes. So when I compile and run, you will see that the output, there's nothing changed, there's no errors due to that. Okay, so comment is purely something additional text which is ignored by the compiler. So that can be very helpful. For instance, I can comment that line, and now when I compile and run, you will see that there's no output of hello world. So that means this line was ignored by the compiler and it wasn't converted into code which the processor executed. Okay. Mr. or Miss Mojela, just unmute your microphone and ask your question. Good morning.
Good morning, sir.
Good morning.
I would like to ask a question.
Yeah.
So which language are you using to program? Because it's my first day attending this class.
Sorry, say again.
Which language are you using to program? Is it A, C++, or HTML, or JavaScript?
Okay. Again, just now I highlighted this part here. And what does it say?
Okay, I can see it.
Okay. So we are doing the C language. We are not doing JavaScript. We are not doing Python. We're doing the C language. The reason why we are doing the C language is because it is rather old, meaning that it's gone through many years of use. So all the errors and the structure is clear. The compilers are good and optimized and that type of thing. And it produces code which runs pretty fast. Okay. And even things like Python is actually written in C, meaning the Python interpreter that compiles Python code was written in C. Okay. Okay. So you can see that we don't need that line. And then we can also comment out those lines so that we only have line 4, 5, and 8. And in actual fact, we can also, we can also comment out this line. And if we now compile and run, we see exactly the same output as before. Okay, so the minimum program that we can write is int main 2 round brackets, 2 curly brackets, and that's it. And that will produce, will compile to a program. It will give us an output, but that actual output doesn't mean anything. It doesn't do anything, but the core structure, the memory allocation, the running of the code, the stopping of the program, all of that is taken care of. So when we run the program, this window is drawn, the output is given, and actually, in fact, the program is. So if I press any key, the program will just close this window. So it's just waiting for me to press that. And we can even make it so that it doesn't wait for that key to be pressed, but we keep it like this as it gives us the opportunity to see that the program actually executed. Otherwise, it will just flash quickly and maybe you miss it because you blinked and then you didn't see that it actually executed. Okay, so the minimum structure is this one, where we have int, main, round brackets, curly brackets. Okay. So what does these different parts mean? Okay. So first of all, this is a type identifier. We will get back to types next week. For the moment, just accept that int is a type. It refers to integer. I will explain it in more detail next week. You can also replace it with void, which means that there is no type and it doesn't return any value. Although when you compile and run the program, okay, you kind of see the same kind of output. Okay. Again, this is also on the web page, where the basic structure for a program is int main round bracket curly bracket with a return value. You don't need to have the return value. In the past, you needed. It depends on the compiler, but the compiler that we have, for the moment, it automatically just returns a value. Or you can say void main, which is the name of the function, round brackets, curly brackets. So these are the type of program structures. And what it means is that this is the main function. This is the code, or how the microprocessor knows that it should start at this point. So it indicates the beginning of my program. And it says, this is the program that you should execute. Otherwise, the microprocessor doesn't know what to do. So when the compiler sees main, it knows to place this code at a very specific place in memory, so that the microprocessor, when it's instructed to start executing the program, it jumps to that memory location and it starts to execute the code from that memory location one by one by one by one. Okay, so main indicates that this is the function that is the start of my program. And it's not main with a capital or all caps. It's main like that. It needs to be exactly like that. Otherwise, it's not going to have the same meaning. Okay. So it's all small letters like that. So this is the minimum. Okay. Any questions on the basic structure of a program? Any questions? Everybody okay? Okay, so let's see what happens when we make an error. So let's remove that one. And now I'm just going to build. And then you'll see here at the bottom, well, first of all, it places a red dot there. And then it says expected declaration before that brace. So it's waiting for something, but the structure is not correct. So the compiler says it found something, but this something is not what it expected. Yeah, because it first needs the opening brace and then the closing brace. or the opening curly bracket and then the closing curly bracket. Okay, so it needs both of them, and you'll see when I insert one, then it adds an extra one, which we just get rid of. Okay, so one way of knowing that you are doing things the correct way is by just placing your cursor next to the brace, and then you'll see its mate is highlighted in blue. If the mate is not there, now you see it's red. It kind of already gives you an indication while you are typing that you need another brace. You omitted a brace, so it's shorting a brace. So you know that you need the mate. If you don't have it, then one of them, so if I delete this one and I go to that one, you see it's red. It says its mate is not there. That's an easy way using the environment itself to know that a brace is missing. The same with these brackets. Okay, if you put your cursor next to them, you'll see that they highlight in blue as well. So if I take away one and I put my cursor next to that one, you see it's red again. So for the brackets, the rounded ones, and the braces, the curly ones, if you place your cursor next to it, it will highlight them either in red, meaning that you short one, or in blue, meaning that it has found its mate. Okay. Everybody understand? Any questions on that? All good. Okay, so you can see that the structure is very important, and if you omit any one part of the structure, then the compiler is going to say, hey, something is wrong. So let's just recompile. And now you see everything is good. It says the build is good. It does give a warning. So that means it will run, but the warning means that we've actually omitted something. Okay. So it doesn't like me to make a void, but void is also acceptable. Okay, so let's just make that back to int. And let's just uncomment this part. Okay, so let's just build and run this again. And we see some output. This value that we've got over here, you will see that it is printed there. The process returned 0. Okay, so in the past, we didn't have graphical outputs. We only had text outputs. So if a program ran and there was some error or it just terminated for some other reason, you didn't necessarily know if it was a good termination or a bad termination. So what we would do is to write error codes. So if an error occurs, we can test for that error, and then we would say return a value, let's say 100, and then 100 would be an error code, and we would have error tables, and you would go in the error table and see error code 100, what does it mean? And it had a specific meaning for that program. Okay, so We'll just repeat the exercise, and now we put, let's say, 10 in there, and we compile and run. And now you will see that here it's reflected, that value 10 that I have there, it now returns that value. And you can play with it a little bit, and you can have any number that you like, as long as it's not too big. And when you say, okay, so you can see that the number it returns is, that number is too big, so it will not do it correctly. Let's see if it does that one. No, still not, still too big. Let's try that one. Okay. So as long as the number is not too big, within the 32 bits, because it uses a 32-bit virtual machine, you can see that it returns the number that I have entered, as long as it's not too big. 1, 2, 3, 4. Okay. So you can see the hexadecimal value as 32 bits. So you can't have more than 32 bits. The number cannot be too big, and otherwise it just truncates it. Okay, it's not important other than understanding that this returns a value which is printed in the output window of my program, in the console window, which says the program returned that value. So you can write yourself a numerical message on termination whether your program is good or not. So normally, if we say return 0, that means that my program terminated normally. There was no error. So if we compile and run that, now when I see the message here, oh, it's a 0, that means a program terminated normally. Okay. Any questions on this statement here, which says return 0 and what it does? So if I have int here and a return value here, when I compile, you'll see that it doesn't give me any warnings or anything like that. It just runs smoothly. Okay. We are now again going to make something not work. You will see that all the instructions terminate with the semicolon. So if you omit the semicolon, what happens? If I now compile, you will see it says expected a semicolon before the brace. So it found the brace, but there was no semicolon before the brace. So that means that, again, the compiler doesn't understand what's going on. So it just comes back and says, hey, you've made a mistake, fix it. Okay, so there's a couple of ways of fixing it. So one way of fixing it is to say, oh, make it a comment. and now the program compiles and runs, so the error has gone away. So you know that that line is the one that is creating the problem. Okay. So if you comment a line and the square block appears somewhere else, then you know that this line is okay. It's not this line that is the one that is making problems. Okay, but if you comment it and the red block goes away and the program runs and it compiles fine, then you know that the error is here. Okay, so it's an easy way for us to find out where the error is. We call it debugging. So just comment it, the one which has the little square box, just comment it out, and then the error goes away. Then you're good. Then you know it's in that line. If the error then moves to another line, then you know the previous one was okay. So you have to search more until you get the error. So this kind of error is one of the most common ones that you will make, together with omitting brackets. Semicolons are also omitted, and I do it on a regular basis, and I've got many years of experience. I've been programming for over 40 years, so I've got lots of experience. I still do that error. I sometimes forget because I want to fix something fast. I'm in a hurry. I don't pay attention, whatever the case might be. Okay, but it's easy to spot. Once the compiler tells you, okay, it's expecting a semicolon, then you know, oh, okay, just check my line. Okay, there's a semicolon missing. Just type it in. And now when you compile it, it's all good. Okay, try it yourself. Make the error, see when you compile what happens, and then fix it again and see that it goes away. Okay, and then drop me a thumbs up that it worked for you and you understand what's going on. Thank you for the feedback. I really appreciate it. Thank you, guys. Okay. Now the question is, what are these things that we have here at the top? Okay. So this directive #include tells the compiler that it should add some additional code in here. Now, what is this additional code? This additional code is code which we refer to as a library. It is code that somebody else has already written, and we can just use it. Okay, so where does it live? How do I get to it? Can I see what's inside? Yeah, sure. We can see what's inside. So first of all, you'll see that these smaller greater than type brackets is used. That says to the compiler, search for this in the path to where this thing was installed. So let's use this one and go to C. And then we go to program files. And then you'll see code blocks. And then if you installed it correctly, you'll see the MingW installation. And then you'll see include. And then if you scroll down, we are looking for stdio.h, which is standard io.h. And here we see standard io.h. So what's going to happen is our compiler is going to include all of the code which is in this file into our program. So it's going to, as if it's typing all of that information before my program here. So what is inside of this? So let's just quickly have a look. Okay, you don't have to open it. It's just, you never change anything in here because this is a standard library. If you start fiddling in here, then you're going to mess up your system, and then you'll have to reinstall. Okay, if you know what you're doing, then you can start changing things in here. Okay, so in here, there's all kinds of defines, etc., but what is important is this line over here. Okay, and here you see printf. So what a library does, it includes descriptions of code. So this function here, printf, actually needs the standard IO to be included so that we have a description for it when I call this function, because this function is not part of C. It is a small program, just like we have the main program here. This is a small program which does something. And in particular, what it does, it draws a window on the screen and it outputs text to that window for us. Okay. So there's a whole lot of things that's inside that little printf program. So this is not a C programming, it's a standard way of writing C code, but it's a function which is not C. It's written in C, but it's not the C programming language. So this printf, which says write this text out to the console window, is actually a small program which we call, and we pass it some information, and it does something with that information. And what it does, it writes out to the console window. Okay, so the standard IO is some additional code which is included, which is needed for my program to run. So let's just change things up a little bit here and make an error, and we put an S in there. And now when I compile, you'll see at the bottom it says in function main, unidentified reference to printfs, and you see there's a little red dot. That means that there is no description for this thing that I'm trying to do. it means it was not declared. So the compiler says, I don't know what this is. I don't know what to do. Okay, so the standard IO is the description for printf. Okay, now it might be that you see a function like printf, but you don't know what to include. How will you know what to include? It's very easy. What you are going to do is you are going to highlight this printf part. You are either going to say Control-C, or you're going to right-click, go edit, and say copy. Okay. And then you are going to go to your favorite web browser, and you are going to type msdn and paste, or type printf, or any other function that you want to know more of. Okay. You press enter, and what should appear is docs.microsoft.com. And when you click on this, it will open a description of the printf. So here on the left, you can see all kinds of other functions, putc and all of that. But you can find more functions here. There's lots and lots and lots of functions. You can see many functions. You don't need to know all of them. We are just going to use a couple, but one of the important ones is the printf. Okay, so you can see that it takes some parameters. So as part of the printf, so int printf, it returns a value. And then it takes some parameters. Okay, we will look at those as we go along. But what is important is this part here. You see it says requirements, and then it says required header. So which library do I need to include? Standard IO. Okay, so it says for printf, include standard IO. So on this website, it tells you that if you want to use printf, you have to include the standard IO, because in the standard IO header, there is the description for printf. Okay, so whenever you are confronted with a new function and you don't know what to include, how do you know? Well, you can go on to the MSDN or the Microsoft Docs network, and by searching for it, you can go down and find the requirements and standard IO. They also give you some examples of printfs, different formatting, hexadecimal formatting, decimal formatting, what all the different parts mean, and so on, and all the expected outputs that you can see. Okay, so based on this little program. So you can copy and paste this program into CodeBlocks and experiment with it and see the particular output. Okay. So again, just repeating it, what you do is you go onto your favorite browser, you say msdn printf, and if you spelled it correctly and all of that, you should get docs.microsoft.com, and when you click on it, you can scroll down and find out what you need to include. Okay, so if you get an error that says undefined reference to whatever, then it means either you've made a typing error or you have not included the correct library. All good? Everybody understand? Any questions? Also, you can go to any of these websites here. And there is see tutorials of what the different things mean, and there should be a place where you can search. Okay. I don't see it now. What you can also do is to just say W3 schools printf C and here is examples of printfs, and you can experiment and play with it. Okay, so there's many ways of getting information, more information on the topic. Okay. You would have seen that in W3 schools, they place the bracket over there. It doesn't matter whether you place it here or where I have it, as long as the brace, the curly bracket, follows directly after the closing rounded bracket. If you don't do it that way, you're going to get some problems. So make sure that there's nothing in between. So there can't be anything in between, instructions in between or so. It doesn't work that way. But the reason why I place it like in line 5 is might be that I have my bracket down here and I'm trying to find its mate. So it's easy if I know in which line it is. So I just basically hold my cursor here and then I can see, oh, it's in line with that one. So that is its mate. So it's easy for me to see. Okay, if it's not in line, then if it's there, then sometimes you miss it and so on. So you can do it any way in which you like, but some methods make the code easier to read and so on. So it's kind of a standardized way of doing things. So just a note, some people program like this. I prefer to do it like this. Then it's easier for me to spot the braces being together. Okay. Again, standard library, we don't actually need anything from the standard library at this point in time, but the template does include it. Does it change anything? No, it doesn't. All it does is add more code into your program, which you don't necessarily use. Okay, is it bad? Not really. Is it good? Not really. Rule of thumb is to only include the libraries which you actually need. Some students prefer to remember a whole lot of includes and then just include them by default. It's not wrong, but it's also not right, especially if you've got a embedded environment platform and you've got very little place for your program, then you don't want to include libraries which are not absolutely necessary. Okay, any questions? Yes. There are not many. Yeah, there are not many of them that we use, so you just remember them. It's maybe 4 or 5. Like for instance, standard IO is used for printf. There's another one, con.io, which we use for input from the console. So console IO, con.io. Later on, we are going to do math.h. And then later on, when we do the Windows environment, it's windows.h. And it's basically those. And fstream, we are going to do fstream for file input. So fstream, standard IO, con IO, math, and Windows 5 that you need to remember. But if you have your handbook, it's in your handbook as well. For each and every one, it automatically includes them. And if you start with a template, it automatically includes those two for you as well. So, yeah. I know the students of eMalahleni, their lecturer give them the libraries at the beginning. Again, for the sake of an exam, whether I give them or not give them, it's kind of immaterial because they are kind of standard to just remember which ones you have to include. If you really want me to give them to you, I'll give them to you. It's not really an issue. What's important is that you understand that if you are confronted with a new function, how do you find out which one to include? That is what is important, not the actual, to remember the actual one. Although in the exam you don't have access to the internet. Make sense? Okay. Good. Any other questions that you guys have? Oi. What can I say? Sorry, now I closed it. What's up? Guys, if you get this error, then it means that you didn't follow the instructions on the website correctly. Actually, I'll just move it over here. So again, go to the website, either how to do the install, either go to internal link or toolchain, and here it explains everything, and you will see that here it explicitly says make sure that you do the Ming W setup. If you don't do the Ming W setup, the compiler will not be installed, the GCC compiler for the Windows Intel AMD type environment, and it will not compile. So please follow the instructions. It's there. If you can't follow instructions, then you're going to have a hard time this semester or this year. Okay. Next week, I am not going to answer any more questions about installation, using the web page, that type of thing. I'm just going to go blink, blink, or I'm just going to post a little rabbit, some nice little animal, buffalo. Just going to post the buffalo. Then you know that you don't know your shit and you've not been following and you've been playing around, and that it is for you to find out how to do these things. I'm not going to repeat myself over and over and over. That's why the resources are there for you to use. Follow the instructions, it's there. Again, I'm not being facetious or anything like that, or trying to take you out or so on. That's why I'm still explaining what to do. But from next week, I'm just going to go blink, blink. Not my problem anymore. Okay, guys, it's there. Grow up, do your bit. As I said, I'm not a policeman. I can't force you to do things. I'm only here to certify, to guide you and to certify you. Okay. Any other questions that you guys have? Okay. I will be uploading these videos of the classes, which means I will have to take down the videos of the classes that's already up there, just so that you can have some idea of what we're doing. So slowly but surely I'm going to take out the stuff from 2021 and replacing it with the stuff from 2022. Okay. What I'd like you to do is to make sure that you understand the IDE, that you know how to fix errors, that you understand how to search for things, what it means to include things. It's on the website. Okay. So it tells you about the include stuff. Okay. And here it explains the hash include and why it is there, and the con IO and why it's there. So it's explained in detail. Just read it and make sure that you understand. So go through the stuff on the website and make sure that you understand. Make sure that you can answer all these questions. Make sure that you can answer all these questions, and then you should be fine for next week. And then we will start in all honesty learning the language and how to write code and so on. So this week and last week was just to get the environment set up and understand a little bit about the environment that we're working in, what type of errors we can expect, and how to fix them, and how to look up new functions. So if I see a get.ch and what it does, go on to the internet and find out. Okay, so for next week, make sure that you are up and running. Everything is ready on your side because we are going to start picking up speed. Okay. That's everything that I have to communicate to you today. If there's no other questions for the moment, I will be available on WhatsApp from time to time to answer questions if there is any. Otherwise, I will speak to you next week. Okay, cheers, guys.